Session 5 is a bit different from the sessions we've had so far. Evergraze and Evercrop and the future woody industries. What we're looking at now is biodiversity and water, which is really a nice way of saying, here were another 6 projects and here's a heading we're going to put them under, biodiversity and water. So not so much a very single-minded, single outcome kind of stream as the others have been, but really a collection of projects that are concerned with the broader aim, the broader environmental aim of the Future Farm Industries CRC to do with managing biodiversity and water. So let's start off by watching the biodiversity and water video, and then we'll get our panel happening. Enjoy.
Environmental focus in this CRC has been really important, and particularly so in the sense that biological assets and water resources have been particular outcomes that have been sought by the CRC, and they haven't just been add-ons to production systems. The 3 key objectives for the biodiversity and water program were firstly to see if increasing perennial vegetation in the landscape provided habitat for native fauna. And secondly, and perhaps most importantly, we're interested to see if increasing perennial vegetation in the landscape enabled us to better manage the water cycle to protect water resources and biological assets. And thirdly, we undertook research and analysis to make sure that any new plants that we were bringing into the landscape or bringing into the country didn't represent an environmental risk in terms of, say, weed or genetic risk.
Biorisk, I guess, was bringing together a new planning framework. What we're doing here is we're trying to protect Lake Toolabin from turning into Lake Tarblin and becoming more or less a saline dust bowl because of the impacts of altered hydrology, extra water coming into the lake and rising groundwater. We've seen salinisation of many of these systems because of land clearing. Toolabin Lake's very important because it's the last freshwater wetland with a wooded lakebed floor that's in relatively good condition in the West Australian wheat belt. The lake is also important because it's Ramsar listed, which basically means it's an area where there's a large number of water birds that come here during lake fill events. Effectively what we did was artificially create a lake inflow event or a lake filling event for just this area by holding water in this bund for about 2 weeks. And we measured the plant responses to that increased moisture availability in the subsurface, as well as what happened with the rising groundwater levels. The research brought together elements of plant ecophysiology, planning processes, and hydrological modelling to try and look at the relative benefit of diverting surface water around the lake and stopping it from flowing into the lake, as well as lowering groundwater levels in the lake using groundwater pumping. There's many parts of a catchment where planting trees may not have the benefit that you expect it will, so it's really important that you understand the hydrology and assess the benefit of planting trees in different parts of the landscape or using CRC farming systems in different parts of the landscape to make sure you get the best outcomes for your biodiversity assets.
In achieving our objectives, we've done a number of things, but one of the interesting components of our work has been the development of new decision tools. For example, one of the components of Biorisk has included developing a new planning framework, and also, of course, the Infer program has been very important.
So Infer arose from a need that we recognised to help environmental organisations do a better job of evaluating and prioritising their environmental projects. From our work that we'd done with a variety of environmental organisations, we could see that this was a really challenging task because it requires people to combine together information about technical things, environmental things, social things, economic things, and that's really quite challenging. So we tried to develop a tool that would do that in a simple way and give them advice about value for money from investment in environmental projects. So that's why we called it the Investment Framework for Environmental Resources.
Infer is very simple at its core. It's really about understanding what it is you're trying to protect, to what extent those values are at threat, and most importantly, can you actually feasibly intervene to manage the threat? If you take the case of the Malort wetlands, there's about 1,000 hectares of wetland habitat here in this area. It's in a very highly modified agricultural landscape, and what this provides is a biodiversity hotspot in the landscape. And of those 1,000 hectares, we've resolved that we've been able to intervene to protect about 380 hectares. We were at a stage in our cycle where we were questioning some of the investments that were being made, and we had a good hard look at some of our investments, and we really questioned whether in fact they were going to achieve the stated benefits of the business cases. And some of the leaps of faith that were taken from what was proposed as an intervention to what the outcome would be, they really were not credible.
Over time, we know it's been successful because we can see how many users we're getting. There are a lot of users now around Australia, and increasingly we're getting users in other countries as well.
It's superior to anything else I've seen, and it's had a profound impact on our organisation and the way we think about investing in the environment. The only things that governments are going to invest in is very credible business cases that are well considered, that have community support, that are based on strong science. And what Infer and the tools associated with Infer give us is the ability to produce that credible business case, and that really does position you well in a very tough fight for funding.
I think there have been real key legacies from the environmental program. The first of these, that we've certainly greatly increased our understanding of how to manage water at landscape scales to better protect biological assets and water resources.
Productivity on our poorer land was very bad. We were getting about 2 sheep per hectare grazing on an annual basis. Our good land was already doing about district average, 3.5. So we thought the best productivity gain would be on our salt land. We looked at it from a positive point of view, saying, well, the salt was here before the land was cleared, so we actually haven't got a salt problem. We've got too much water. This area here, it gives us a good overview of what our system is. In the background, we can see a line of trees. The idea is to cut the water off coming down off the high ground. Then on my right, behind me here, we've got perennial pasture, so the water that gets past the trees then gets used up by the perennials. Left behind me is an area that used to be very shallow water table, going saline with bare scald. The water table at 1/2 metre. The water table is now 2.5 metres, and as you can see, the scald's gone. In front of me, we've got an oat crop that will go about 4 tonne, simply because we've used up the excess water before it's got there to create inundation. Our system is putting perennials in and grazing them to the maximum, getting the maximum production out of them, which means we have to replace them fairly regularly. We don't look after them, they're not mollycoddled at all, so we've been able to carry on our salt land, or our waterlogged country I prefer to call it, similar carrying capacity to what we have on our better pastures. The CRC has been a great thing because CRC has actually been going back for 14 years now, so we've had 14 years or more of research, of collaboration by farmers, researchers, ag departments, all those sort of people coming together to get packages that'll actually work on salt land. And some of the great things that have come out has been like the Messina, getting legumes into our salt land, which has been almost the holy grail, if you like. Things like Tetera, and it's sort of backed up what we've been doing and known anecdotally. Good figures coming out to say that this stuff actually works and it's a dollar value. We have to try and replicate nature, or else we're doomed to fail down the track somewhere along the line. So by planting trees in the right spot, we're not losing production, we're actually helping with biodiversity, using water on our salt land. We're actually getting soil microbial activity back into the ground, all this sort of stuff. And that all adds to the mix of working with nature and not against it.
The challenge going forward is to take the work that we've done to date and turn it into serious management actions which continue to deliver the outcomes for the biological assets and water resources of our nation.
Yes, I just missed my cue on that one. Apologies there. biodiversity and water is our final session, and pulling together some fairly not necessarily strongly related projects. Join me in welcoming to our panel Ken Wallace from the Department of Parks and Wildlife WA, Greg Summerell from the New South Wales Office of Environment and Heritage, Jeff Park coming up behind Greg from Natural Decisions over, I think, also in WA, and Ian Walsh, farmer from Cranebrook in WA. And clearly whatever I'm doing is very off-putting, so they've chosen to leave a big gap, an empty chair between me and them. But that's not going to save you, fellas, I'm afraid. It is a different situation from the other programs, which are very much more focused. What we're looking at here are the projects that the CRC has undertaken for its broader aims in looking at biodiversity and water management. Apart from Infer, which we've heard about on the video here, and some of the salinity management and examples we were given there, what other work has the CRC been doing to look at biodiversity and water in the program?
Yeah, thanks, Bernie. There was two major projects that weren't listed in the video at all. The first one was the Production Perennials for Biodiversity project, which looked at the supply from the woody perennials of resources for native fauna. Now, while in the original salinity CRC the focus was on mallees and fauna, in this CRC it was on saltbush and fauna. Now, there was no doubt that we found that the saltbush does provide habitat for a range of bird species such as babblers and the white-fronted chat you see on the screen in front of you. And also, something that surprised me intensely, I must confess, was that sleepy lizards can almost live out their complete life cycle inside monocultures of saltbush. And it really wasn't what I expected. The other interesting, just a little sidelight on that, was that the health of the sleepy lizards in the agricultural zone was not as good as the health of the sleepy lizards in the rangelands. So there's a series of questions that have come out of that work which would bear following up at a later date. The thing I'd want to emphasise out of this particular project was that although definitely the mallees and the saltbush provide important habitat for some species of native fauna, the gold standard is the remnant native vegetation. A far greater variety of species will inhabit the native vegetation, so we can see the perennials that we might put in the landscape as bolstering particular resources, but they're really no substitute for the remnant vegetation that we need to protect in the landscape. The other project that was not mentioned, was a very important project, is CAT+, which is effectively a modelling platform which brings together land use, geomorphology, climate, hydrogeology and other information, and spits out scenarios and interpretations of the impacts of some of the perennials we might put into the landscape. And in particular, the focus was on evergraze. And so that, for example, and this, I'm not bothered at all about looking at the detail, I just want you to get the overall impression that in the Wannon catchment, they looked at the impact of a whole range of perennial systems at different percentages on stream flow, and lo and behold, it's no surprise, yes, of course it affects stream flow. It just depends on what your trade-offs are and what you want to do where and in what part of the landscape. And so that there was actually an impact on, even in dams in not that many years, I must confess, but there was an impact on stream flow in general and also on dams. The other one is the Tarcutta catchment in the Murrumbidgee area. And here they looked very closely at the impact of evergraze solutions in different parts of the landscape, lower, middle and upper catchment, but also on different soil types. And to me, the interesting thing here is that it does show quite clearly that in some cases, if water quality is your issue, for example, you would want to be using evergraze solutions down on the valley floor in some of the areas that were prone to waterlogging and salinity. There are other areas in the catchment you would not want to use evergraze solutions because the trade-off in terms of loss of water flow would be too great. So I think these projects, this project in particular to me, Greg, I must confess, I like the way this really emphasises that we all know you need to think very carefully about where you plant things at a catchment scale and the impacts they're going to have. And I think in some ways this project brought it out probably as much as any. And I should probably stop there.
You didn't even see me doing that yet, but well done.
I was ignoring you. I was looking at the open chair for all the questions we've decided we'll go to the chair.
I knew there'd
Greg's
be a
idea.
strategy in there somewhere. Greg, we've just heard a bit about CAT Plus from Ian there, but how's CAT Plus work helped in planning and investment on a regional level?
So for us in particular, can outline why we'll charge with the project, understand the impacts of land use change, bringing the perennials in, the impacts on the water quality. So when we're looking at land use change, especially in this particular catchment that I'll talk about here, Tarcutta, 2,000 square kilometres, massive catchment, rainfall from the highlands up around 1,000 millimetres right down to the lowlands, 500 millimetres. So big grading in land use, everything from forestry, tourism, sheep grazing, cropping. So all those land uses all in there. And why it's important regionally is it allows us, and this is where we use the modelling, especially when it becomes spatial and people can see their position in the landscape, it allows them to understand a community conversation of what am I doing in my part of the catchment and how is that affecting us as our community. So it's allowed us to get the conversation away, not just about the farm and my impact on the farm and my salt skull or my water quality issue, but how does that impact and how are we helping each other as a community throughout the catchment. So regionally, that's the real big part that's gone into our planning.
And you feel like it's really achieving that?
It is, because the way the project's been put together is through a lot of participation by the landholders in the catchment. A lot of land use history had to be developed through the landholders, and because of that, they were engaged in the creation of basically the smarts behind the model, the information behind there. Because they understood that, they understood the results that were coming out to be able to have the conversation. The big part is just having the conversation. And so allow the conversation.
Yeah, and again, being driven by the questions from on the ground at the start. So
exactly.
Everyone's involved.
Yep.
Now, Jeff, you were one of the developers of Infer, which we heard a bit about in the video. So there are quite a lot of complex synergies and trade-offs involved in catchment at regional management level. What do you think the next steps might be in improving our ability to deal with these trade-offs?
I guess the first thing I wanted to say, I wanted to thank the CRC for backing Infer, because it's been fantastic to have that support. We've worked with half of the 50-odd NRM regional bodies around Australia, so we've had lots of experience in the decision-making setting. The context is limited budgets, hard decisions. In terms of synergies, we're now starting to get some runs on the board in terms of the project that Damien spoke about, where farmers in a very productive agricultural landscape are able to look after really important environmental assets. And there's a perception that farming and conservation don't go together. I think that's these sorts of examples show that that's not the case. In terms of trade-offs, though, there's some pretty tricky future things to look at. We're doing quite a lot of work on water quality in the Great Barrier Reef at the moment in a couple of regions with Infer. And one of the things that we come up against all the time is that people set quite unrealistic targets for the environment in terms of what can be achieved with a limited bucket of money. And I think what Infer does is it helps you understand much more transparently about what those situations are, so that you can actually at least bring the information to the table to deal with complex trade-off decisions.
And I guess one of the temptations that makes people do that is so that their project stands out, more. But if everyone were to use a program like Infer, everyone would be getting that same feedback, and across the board would be getting more realistic aspirations, I guess, for projects like that.
That's right. I think there needs to be stronger rewards for really well-planned, rigorous projects that integrate, particularly the economics of land use change. I think farmers are often asked to do too much for the public good, and this just sort of makes it much more transparent as to what is required. So, yep.
Speaking of farmers, Ian, you've been involved in working with not salt-affected land, but waterlogged land on your property, your beautiful property that we've seen a few times in the video there. You've been involved in this for a couple of decades now, and you were involved with the Dryland Salinity CRC before this. You're really walking the walk on the farm. What do you think are the most important CRC research, or what's the research that's contributed most to your decision making on your farm in practice?
Yeah, look, I think it's a fairly broad question, really, and I think the CRC has really confirmed what we have been sort of doing earlier on. I just want to go back a step. Many years ago, there was research done showing that saltbush was of no value, and yet farmers were experiencing the fact, well, you know, we're getting greater carrying capacity, water levels are dropping. You know, what was this research all about? The research wasn't wrong, but the research was too narrow. We found out that by creating this new environment, we were getting good productivity on the ground where we weren't getting before. So actually, the saltbush was driving a whole different system. It's a bit like with the sleepy lizards. You know, you're getting a whole new system happening there, which was driving it. So the saltbush itself wasn't of great value, although later research has actually found it is of better value. But it's what the saltbush was doing to the whole environment, and so that was creating a better understory, annual pastures underneath previously degraded ground. So that earlier research was actually very important to drive questions as to what was going on. And so I think, for me, one of the big things with the CRC has been bringing all these researchers together and actually asking all these questions, what's really happening here? And by bringing people from all over Australia, farmers and researchers together, and people into biodiversity type of stuff, it's really being able to, for me as a farmer, to go to other farmers saying, here's what it does, here's, you know, we're not talking rubbish, we know what we're talking about, here's the research to back it. So.
Here's what it does, we're not talking rubbish. I think that's a great takeaway from the entire...
And the other thing is, too importantly, farmers are... we work natural resource management. We're working in the natural resource management. You can't separate farming from natural resource management. It's the one and the same thing.
Terrific. Thanks very much, Ian. We have some time for questions now, so if you'd get your hand up for the microphone. And while we're waiting for our first question there, Ken, at the end of the video you mentioned the challenge of converting research into action. What do you see as some of the key issues in making that conversion?
I've been working in the area of water and interaction with biodiversity for something like 30 years now, and it scares me to think how long it is actually. And I'm highly conscious that if you don't have long-term data sets, if you don't have long-term interactions between researchers and operational people, you will not achieve success. These are not short-term issues, they're not short-term problems. We're constantly lamenting the fact that we don't have enough data of a sufficient quality to do address some of the questions that we'd like to. And actually, looking forward, I must admit, I'm a person who's now approaching, I call it transitioning not to retirement, transitioning to a different lifestyle. and I actually am quite concerned that the capacity, when I see the increasing number of 3 and 5 year timeframes in projects, I seriously ask myself how people like Greg and others are going to get sufficient data over sufficient timeframes to be able to make the inferences and judgments and analyses that we need to make as a nation to make good decisions. I mean, the Mallee project's another one where that's been going for 22 years now. And you can see, I've been involved in that project and I can see the end that really is on the verge. But are people in the future going to have the ability to carry out projects for those length of times? I wish I had an answer for people. I don't, but it is certainly an issue, and I think if we don't address it, we'll be a poorer nation.
Thanks, Ken. Do we have any questions from the audience? How do the people who might be stuck with 3 and 5 year timeframes and not getting long data sets feel about what Ken said?
I think you've still got to make decisions, and the main thing is to acknowledge the uncertainty and the gaps in knowledge that you've got. But I'm a pragmatist, I guess, and that we work with a lot of pragmatic organisations and people, and I think I agree with Ken, but you've also in an environment where you've got to support people to make perhaps not the best decision, but at least a better decision than they're making now.
Greg?
We're definitely focusing on, because of the issues Ken's highlighted about the transparency in the decision making. using the best available knowledge, whether it's come from a local landholder or whether it's something held within a data set. As long as the transparency is there, and with the regional bodies I've worked with, they've always said, you know, if you give us an answer today and tomorrow it's a different answer and we've invested in a land use change because of it, we're not going to shoot you because we made on the best available information. It's if we don't use the best available information, that's when we're not, you know, serving our dues to actually.
Is that when you're going to get shot though? Because it sounds like
close to it.
Okay. Yeah.
Yeah.
Yes. Make sure that that information is up to date. That's all I can say.
Yeah.
Do we have any questions? No? Okay, great. Well, let's just move on. Thank you very much to the biodiversity.